Welcome to Chapter 20, Section 2. We're going to be talking about generators, motors, and we're actually going to leave mutual inductance for the next video. We're going to group that with 20.3. So what we're going to do today is we're going to describe how generators and motors operate, or how they work, and we're going to explain the energy conversions that take place in generators and motors. So generators are machines that convert mechanical energy into electrical energy. And remember that mechanical energy means kinetic energy, okay, or potential energy together. And specifically, remember, this usually has a lot to do with motion. So these kinds of generators are actually, in one way or another, they are a part of every energy resource conversion we use today, as long as that energy conversion has the goal of electricity. So this is one of the reasons that we're learning about this. It's very important. All of these are examples of different ways that we do use generators every day. So in dams to generate electricity, in windmills, in nuclear power, and in geothermal energy. All of these actually use generators to create our electricity. So that's why this is important that we're learning it. So let's begin to take a look at what actually happens in a generator. So what's happening here, okay? What we have, the way they work is you have a loop of wire, okay, and a magnetic field. And we're going to, this is our EMF. Remember, EMF is kind of like a voltage. It tells us that it's generating current or volts. So as we look at this, the first thing we have here is we have this magnetic field. And at this position of the loop, okay, this is rotating. So that's what this arrow means. And this is in your textbook, okay, so you can check there to look at it also. So it's turned a little bit, but it's at this point, this top is moving parallel to the magnetic field. So right now there's no induced current, okay? So then it keeps rotating, right? It's turning around this way. And now it gets to this point here, 90 degrees further. And at this point, it's entirely perpendicular to the magnetic field. So what happens is we get a lot of current flowing because of the induced EMF, okay? And so see here that it's positive. After that, right, it keeps turning. It goes back to being parallel again. At the parallel point, we get 0. And then as it keeps rotating, we come back up to this perpendicular position once again. But this time, please notice that it's opposite direction that is flowing, okay? And that's because the loop is the other way around, right? This is the other side of the loop, okay? So what happens is because we get this alternating between the positive and minus in our induced current, this is an AC generator, okay? So this generates AC current, okay? And it's because of this shift from positive to negative, okay? So as we keep looking at this, okay, generators like this always generate AC current, okay? It requires two separate loops here, okay? And then they connect with these little brushes, okay? These are metal brushes so that they're always conducting electric current. And it will just keep turning in this. And as you turn it, you do have to turn it. You're causing the motion. And you turning it is why it converts mechanical energy to kinetic energy, okay? So you turn it, or something turns it. In a dam, for example, water turns it. But it needs to be turned. And that turning is the conversion from mechanical energy into electrical energy. Okay. We can also do DC generation. In DC generation, it needs to look a little bit different. So what happens here in this case is we have this one ring instead of two. Okay, and this is called a split ring. So it's a split ring instead of two rings. Okay, and what that does is because it isn't one single loop, it allows it, as this rotates, to also flip which side is connecting, and so that keeps it at the same, like they're both positive or they're both negative. So the current is always flowing in the same direction. Okay, the other way that we can create a DC generator is to use many loops instead of one loop. So, and that's talking about this loop here. So if instead of just one loop here, we took that and then we also had one that went this way and another one that went that way, and my drawings aren't very good But you can imagine if we had a whole bunch of different loops here, then you can always keep just the part of it that's positive, or the direction that you want for the current to be. Okay. All right. So the other kind of thing we can talk about is motors. So motors are the opposite of generators. Okay, so they take electrical energy and convert it into mechanical energy. And they work almost the exact opposite of what we just looked at. So they are they're built almost identically. Here we have a split ring. Okay, so it's like a DC one, but reverse. And what happens now is you connect this to a battery. So you're taking that electrical energy, right? And when you put this through here, it's going to generate a magnetic field. So if our current happens to flow in this direction around the loop, then we would have the north end of the magnet kind of facing us out here. And you notice this is south, right? So they are going to attract, which would pull it towards each other. But as it goes around, okay, then it's going to flip, and we'll keep getting that north being here, and it will keep repelling. And so what this does is it just causes it to rotate and rotate and rotate and rotate. Okay, so they attract and repel alternately, okay, with this magnet in place, and it keeps going. You are actually going to get to build a motor in class. Yay! Okay, that is our fun lab for this, the end of this year. It'll be your last lab. So we'll get a chance to do that next week, and that will help you understand exactly what's happening a little bit better. So that brings us then to the end here of chapter 20.2 for now. We're going to have the rest of it in with 20.3 because it makes a lot more sense. So I will get to that on the next video and see you guys in class.